Here's a solution to one of the homework problems in section 7.1, and this one is similar to one that we had on the worksheet from class with batting average. So in this particular version, we're told that the player has a 0.346 probability of getting a hit. And so that means that if we were to have him try to get a hit for 600 times, it would be like asking a sample of 600 people some question that each individual person has a 0.346 probability of answering, say, yes. And so we can imagine that over different 600 game seasons, at the end of each 600 game season, the proportion of hits that the player really got would be a sample proportion, so we think of that as a p hat. So the distribution of the sample proportion should be centered, if I could write, should be centered on the actual probability. So the true proportion in the true proportion in the population is the center. This is the p hat distribution again. I erased it. And then we have 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. And we learned that the standard deviation, in this case, it's actually called standard error sometimes, but standard deviation, in this case, has this nice formula. It's the population proportion, so 0.346 times 1 minus 0.346 divided by sample size, all under the square root sign. And so in this case, if you actually figure that out, that's the 0.019 that you see floating around this problem. And so that's the standard deviation. That's how far you go for each of these tick marks. Okay, so that's what it's going to look like, and that's just based on reading the problem up here. And so now we just have to answer the questions that they gave us. But having a picture in front of you often helps. And in fact, if I had more room, it wouldn't hurt to label these tick marks just so that I have some sense. So this would be 0.346 plus 0.019, and then plus another 0.019. So this is what we're doing in class. Okay, so now we have to figure out which of these is most likely, and I see I just had it fill the answers in, otherwise it wouldn't show me all the parts. So the distribution is bell-shaped. They all say that. Yep, that's bell-shaped. We know that. The center of the bell-shaped curve should be this batting average. It should be the population P. So the center of the bell curve is 0.346. So right away, it's not going to be this choice, and it's not going to be this choice, because they're just making shit up here about what this is centered on. So it's either A or C, centered on 0.346, and then it says the minimum value is 0 and the maximum value of 1 standard deviation. So the minimum value in here, the maximum value here. But that's not what we learned about these bell-shaped curves. There's really not a particular minimum or maximum on these curves. They keep going. Obviously there's going to be, some point where it runs out of steam here. But basically the minimum possible is always 0 and the maximum possible is always 1 for a proportion. And so saying the minimum is 0 and the maximum is something about standard deviation doesn't really make any sense. On the other hand, this other statement, the majority of the distribution lies within 3 standard deviations of the mean. That's always true, right? So that has nothing to do with this particular problem. Anytime we have a normal distribution, one of these things, the majority of the distribution lies within 3 standard deviations of the mean. That's a true statement. So they just threw that in to sound all technical, but really the only thing they're telling you that's specific to this problem is this thing about being centered on 0.346. So the answer to this is A. Now here they say, explain why a 0.327 or 0.365 would not be an especially unusual batting average. Well, if you drew this with the scale, you would see that 0.327 is this value right here, and 0.365 is this value right here. In other words, those are the two numbers that are 1 tick mark up and 1 tick mark down. So that's 1 standard deviation above the mean, that's 1 standard deviation below the mean. So if you label this, you'll see that those two numbers are going to be your labels there. So the first choice says these batting averages are 3 standard deviations from the mean. They're not. This is 3 standard deviations. That's not where those things are. The second choice says these are one standard deviation from the mean. That is true, and therefore it's not unlikely, right? It's certainly in this vicinity, not strange, that you would have a batting average like that. And then the other one also says that there are 3 standard deviations of the mean. So the only one that actually is truthful in the first sentence that it says is this one. These two numbers are 1 standard deviation from the mean. And if you just go ahead and draw this picture, just from the description, you'll have that sitting right in front of you, and you won't have to worry about trying to parse their words.